Welcome to our March 3rd, 2023 Forage Forum Friday. So we're excited to have you all with us. So thank you last week to Dr. to Dr. Johnson for hosting us last week as I worked on some winter storm ice cleanup, and we still have plenty more to go, but 11 inches of snow today kind of put a damper on that. So, but we're here, we're still surviving, we still have power. It's a good day. So it's my pleasure today to have with us Dr. Teresa Steckler. She joins us from Illinois Extension. She has great extensive background in beef research and forages and soil health and all those good fun things. So we're excited to have her here with us today, and I will let you go ahead and take off with it, Dr. Steckler.
All right. Well, thank you very much, Lisa, for the invite. I always enjoy talking to new groups, getting questions and stimulating the conversation. My philosophy is, I have a PhD, but no one knows everything. And it's always great because you just never know where those from and use those in future for other producers. I am a livestock specialist for Illinois, but my background's actually reproductive physiology. My area of specialty in that is estrus synchronization and fertility and prenatal programming. Essentially, I'm really interested in things that happen when the fetus is in utero or the developing embryo and how that affects adult fertility. So I have morphed my research program into ticks and tick diseases. And I'm not really doing any research in forage management. I do dabble in it, if that makes a lot of sense. So that's enough about me. Let's get on with the program, because that's the more important thing, is sharing ideas. And I named this the Triad. And the reason is ultimately this is a triad because soil, plant, and livestock health are so intimately related, and hopefully by the end of this conversation you'll understand why they are all related. And it takes all three, in my opinion, to have some really healthy soils and plants and livestock. So this is basically the triad. So you have the soil health, and the plant health is dependent on your soil health. Your livestock health is dependent on your plant health, and then your livestock health goes back and feeds into the soil health and plant health. So it's as I said, it's a huge triad. And if you think of it that way, it makes, in my mind, it makes more sense. And you start thinking about things you hadn't thought about as far as the synergies amongst the three. So we're going to go through healthy soils first. What do we really need? And these are the four main components. I mean, these are very simple, and they, for the most part, they make sense. I mean, you got to have minerals there. The plants need minerals, regardless of what anybody says. You have photosynthesis. What are you've got a lot of chemical processes that take place during photosynthesis. And photosynthesis itself is a change of ions from one form or from one place to another. So, and to have those ions, you've got to have your minerals. Water is very important for all life, and without that, you have a desiccated plant and it doesn't do anything. Air, key to life as well. Not much need to be said about that. And organic matter. So these are the four things we're going to go through briefly. Mineral solids. So mostly that it means is it's a sand, silt, or clay, and those contain all of the other minerals, or most of the other minerals, and you can read them right there. Though all of those are very important for life, and whether it be a earthworm, pill bug, whatever, all life is dependent upon oxygen, magnesium, calcium. If they have any kind of nervous system whatsoever, they need these minerals. So then you move on to your water. They usually call it the soil solution. because it's the one that contains all the dissolved nutrients, and that's how your plants uptake the nutrients. And essential nutrients are made available to the roots through the soil solution. Of course, air, you've got to have oxygen in the water, in the soil. It's got to be able to permeate that, because you have respiration going on in the roots, and that carbon dioxide needs to get out as well. So there's a multitude of things going on in these soils that a lot of people, they've probably thought about it up to a point, but maybe didn't put all the pieces of the puzzle together. So what do we need for healthy soils? We've got to have those clumps of minerals and organic particles. Without that organic particle, you're not going to have the thriving ecosystem in there. The pore structure, that's got to allow for water to permeate, because we have some soils in southern Illinois that are clay all the way up to the top of the ground. And you know what, that will, for the most part, a lot of the rain, especially if we haven't had rain in a long time, just rolls right off, because there's no pores for the water to go down into. And in Arkansas, where I was at, we had sandy soil. So yeah, it went into the soil. However, it leached out, or I should say leached out, it just dried out very quickly. So you go from one extreme to the other. And most people will realize that in central Illinois, in the Midwest, we have some of the best loamy soils. And when those soils are at their peak health, they hold a lot of water, but they allow for the exchange of gas and CO2, and they have great organic matter in them. So you want good soil tilth. It shouldn't be compact. But it shouldn't be like sand where everything just runs through. Sand is basically silica. And until you add organic material to it, it'll grow things up to a point, but the plants don't grow as well as they could. So healthy soils, last two lines, promote rainfall infiltration for water storage for the plants, and they allow for good root growth and drainage. So we want sufficient depth and before we get down to the bedrock or compact soil layer. So soil degradation. I've seen this on several farms, trying to work with them to get their soil health back to a point where it's what we talked about in the previous slide. So basically, there was a gentleman that worked for Extension, and I'm failing to remember his name, but he did a lot of work with cover crops, and had taken samples throughout Illinois, and basically the continued tillage of soils in Champaign County has really degraded the soil structure there. And so if you have the intensive tillage or soil erosion, that just leads to that organic matter decreasing immensely. And in Champaign County, I want to say, I may have my numbers off, but it'll give you a rough estimation. We went from like 120 down to 60. So that's why there's a push for the cover crops, is to build that soil organic matter up. So if you have less organic matter, you have the surface becomes compacted, and you get these crusts that form. Then you get more organic is lost, and then you get less water storage. You get less crop yields, and eventually you'll have hunger and malnutrition. One of the things that you will also see is a huge loss of diversity of your soil organisms. And it's only been in the last 20, 30 years that an appreciation for these soil organisms and the multitude of organisms. some of the research that I did with the geological survey, we were looking at PCR, just looking at the mass of DNA from soil organisms. And so what we were seeing was a 4 to 10-fold decrease in soil organism numbers relative to in those areas with intensive tillage versus areas that were better managed. So those, and you could tell from plant production just how much better those soils were. So this is one of those things that people need to keep in mind, is how you work that soil, and that soil can become degraded over time. And you can even see this with some of our pastures by just the continuous, it's not from a tillage point, but from a continuous pull off of forages and not putting back anything on those soils. And not all soils are equal. As I said, I talked about Arkansas, where a lot of that soil is just, well, I wouldn't even call it soil. It's just sand. You get into some of the tree areas where we've actually had some residues put down from the leaves. You get a little bit better soil structure, but it doesn't compare to anything like you would have for, just say in central Illinois or even in southern Illinois. And southern Illinois has really high clay soils. We have a very, I think it's about 4 to 6 inches of topsoil in some areas before you get down into just a hard clay. So there are many limitations, and the problem is that low organic matter. Again, the texture extremes, as I've already described, poor drainage can result. The sand has way too great a drainage. The clays have poor drainage, and the layers that can restrict root growth. Certain areas, over in the zoo, the topsoil is only 3 inches deep, but they still farm it. So if you can imagine trying to maintain that organic matter in 3 inches, that's a tall order. Something has to be done to replenish those soils. So it's very important to understand those soils that you're working with. The USDA actually has some really great soil maps, and it gives you a good estimation of what's going on in your area. And then keep in mind, it doesn't matter if it's a really, really poor soil. You can build it into a productive soil. So it may take time, but once you get started and you start seeing the progress that can be made, it's well worth it in the end. So what are we looking for? And there are scorecards, and so you can look for the presence of earthworms, erosion, tillage ease, soil structure and color, water infiltration rate, drainage, all of that. So when I go to a field to do a new assessment, I have a shovel, I have my soil probe, and I make that, it's pretty much mandatory. If you work with me, we're going to get an assessment of your soil health, because that tells me where we need to go or where we need to start from. And it gives me an idea of what we need to do to bring back fertility. It could be something as simple as what we're going to talk about as pH that can bring back some fertility. So again, talking about all of this, when you have the organic matter in these soils, that leads to biological activity and diversity. It's just not activity, but you've got to have the diversity. And once you have that diversity, guess what? You have a lot less soil-borne diseases and the parasitic nematodes, and that just leads to a much healthier plant. And you can read this whole slide. It's a really great way of breaking it down. All of this comes together and just creates a much healthier plant. You have a healthier plant, guess what? That plant's going to provide the needs of that livestock that you have on that farm. Because if you think about the cattle that's out on that pasture, I'm going to use cattle primarily, substitute sheep or goats. You get a pasture that's been overgrazed for years, and there's a couple down the road from here that were purchased from a gentleman who spent years building up the soil and had these beautiful fescue pastures, and he had these warm season pasture, and I don't remember what was in it, but he had no weeds, no nothing, and he ended up passing away. Farm was sold, and within 4 years, the pastures have turned to basically Broom's Edge. If anybody knows anything about Broom's Edge, that's a good indication that there is something really off in the soil, whether it be from a pH or a phosphorus perspective. So all of these things are necessary for great plant health. So if you have good soil health, that leads to plant health, which leads to your livestock health. And this is just the things that plants need. As I mentioned, there is the photosynthesis that occurs in the plant. Well, it needs several minerals to make that work. And I should have brushed up on my photosynthesis. I can barely see the picture of it, but I'm trying to remember. Manganese is one of them, and oxygen and hydrogen is in there. But these are what everything that the plants need for growth. And the other thing is, if you have those soils that just hold moisture, that then there's not that oxygen carbon dioxide exchange. Now, there are certain trees that can withstand. Cypress live in muddy, murky, but they have the root nodes that come up above the water. So they still, regardless of most of their roots being in the water, still need oxygen down at the root level for transpiration. This is a good point. Most nutrients in soil organic matter are not available because available to plants because they exist as part of a large organic molecule. So it's got to be in a simple form for the plants to be able to uptake it. However, it's those soil organisms that decompose that organic matter. And once they start decomposing that, and basically their feces excreted is what provides the nutrients for the plants. So if you think about earthworms, and if you ever pick up earthworms and you see the castings, that casting is going to provide so much so many nutrients for plants to grow. So having those earthworms, digging up a section in a field and looking at the number of earthworms can give you a really good clue about the health of those soils. This is a snapshot that I took out of a book, and it's from Dindal. And if you can imagine, in 1972, these were the basic ones, and there's a whole multitude of others now. So you, at the very, very bottom, you have your organic residues, whether it be a leaf, dead animals, even corn, whatever. But then you have what's called your first level consumers, or your primary consumers, and you have your fungi, your bacteria. Then you also have your earthworms and snails and slugs. All of those go to work down that residue, and it's very important that they break that residue down to a different form. If you think about what fungi do, even in the woods, especially on fallen trees that have been there for a while, you see a multitude of different fungi that are growing, and those fungi are breaking down that cellulose into a different form that's more readily available for other insects or for other plants. So you can see through all of this that they have up to the tertiary level, your centipedes, your ground beetles, that kind of thing. So if you could think about how many organisms that could be in one cup of soil, and you actually could sort through it and identify everything, and make a connection or a distinction between exceedingly healthy soils and those soils that are not, you will see it's astounding about the difference in the numbers. And as a take home, I was in South Dakota last year for a tour, and we went to a farm, and it's a cattle farm, but they also do some row crops, and they actually plant wheat and rye. And next to the house, the building that we were in, we took a walk out there. And keep in mind, when I was out there, I think it was April-ish of last year, they hadn't had any rain. They were still in a severe drought, and they had received about a half of inch to an inch of rain right about the time that I was showing up. So there was runoff everywhere while I was driving down the interstate from Sioux Falls. And when I got to the farm, I was looking around, and it's like, hey, there's not a lot of standing puddles or anything. And on the last day of the tour, we went out to one of his fields where he had his winter wheat growing. And he took a shovel out there and dug into that earth, and he showed us that he had wheat that was 8 inches tall, and the soil itself was full of earthworms. You could just see the activity of different, the roots itself were massive. They were deep. They were about 10 inches to 12 inches deep, and there was no runoff, plenty of earthworms and other things crawling around in there. And he attributes that to the fact that, one, since they have a lot of livestock, they rotate the livestock through a lot of the pasture, through those fields. But he also attributes to the fact that they've gone to mostly a no-till situation. So by doing the no-till, they're actually conserving the organic matter, and that you could tell from that field versus fields that they didn't own where there was other wheat planted, just the complete difference in growth of those plants. So that was an eye-opening experience, to say the least. And it was just reaffirming what, I was trying to practice with the livestock producers in Illinois. So what's one of the biggest things that impacts our forage growth and production? And that's soil pH. Because that soil pH is going to dictate how well those plants grow, because that'll also dictate how those minerals and everything else are actually available to the forages. But each plant needs different, has an optimal pH, a better way to say it. Nutrients can be applied via fertilizers or manures, and they could just be lost because they're just not available for the forages. And we want to minimize our nutrient runoff issues. Everyone's well aware of, the different things that are going on, especially the algae bloom down south from the Mississippi and things. So minimizing runoff is important. There's a lot of different things that can affect the soil pH. Basically, what materials there ahead of time. Clays have their own little weird cation and anion things going on. The type of microorganisms and the organic matter decay. So if you could think about having certain organic matter that is sitting there and decaying and just makes everything very, very acidic. Temperature. If you have very little cool temperatures, you're going to have less decay going on. Rainfall. If you don't have any rainfall, guess what? You're not going to get the organic matter to decay. You have too much rainfall, guess what? That just leaches all of the nutrients away. So there is a fine line for everything. It is what it is, but you just try to minimize or try to maximize or mitigate the soil pH. And that last sentence there, the high yielding crops absorb the basic soil neutralizing elements. calcium, magnesium, and potassium. And as the crop's yield increases, more of these nutrients are removed from the soil. So there you go. You get a reduction in your soil pH. So anytime you can add the calcium, magnesium, and potassium back, that will change your soil pH. So in general, grains contain less of these minerals than leaf components. So typically high yielding forage crops affect soil acidity more than harvesting crops for grain. However, if you rotate, which that's something that farmers used to do years ago, is rotate. They'd put row crops out for a while, then they put it in pasture for a couple years, and then they rotate back to row crops. I don't see row croppers doing that, but it would be great if they could do that along with some no-till practices to maintain the soil health. And this is a chart. It's readily available. That just shows you the accessibility of these different minerals, and depending on the acidity or alkalinity, whether or not they're actually available. So easy to find, or I can provide this for you at a later time. But as you can see, like for iron, it's a completely different profile than if you get down to aluminum or potassium. So what interactions are out there? Phosphorus generally is low in our soils. So, and it's only second to nitrogen as the most limiting nutrient for plant growth. So this was research from the Noble Research Institute, and it showed that 70% of soils needed an additional phosphorus added, and 40% were severely deficient. And that's at the Noble Research Institute, where they do a lot of pasture research, and it's out in Oklahoma area someplace. So why is this of importance? Well, because it's used during photosynthesis. And so that if your plants don't have phosphorus, it can't produce, or it can't go through the photosynthesis. So therefore, you're going to have markedly reduced plant growth. It's necessary for legumes for nitrogen fixation. So if you have a deficient soil, your legumes probably are not going to be able to grow very well either. Root growth and development, essential for the transfer of carbohydrates, crucial during the plant's establishment phase because of its role in photosynthesis, root growth, and energy development transfer. So if you've got a stand of grasses that you've planted and they're really not growing worth a hoot, and you didn't get a soil test, it might be to your advantage to get that soil test and get some phosphorus on there if it comes back as deficient. Or better yet, just have the soil analysis done before that. So consider this. For each ton of Bermuda grass, I couldn't find anything for fescue, so I went with Bermuda grass. It will remove 43 pounds of nitrogen, 10 pounds of P2O5, and 48 pounds of K2 from the soil. Even though nitrogen is applied yearly to introduce grasses to obtain a yield goal, it should be obvious that if the P and K removed in hay is not replaced, it can return to a nutrient mining operation because so much of P and K are removed each year. So at minimum for Bermuda grass, for each ton, you need to put 10 pounds of potassium and 48 pounds of phosphorus back on these fields. And you can tell from one year to the next by how well your Bermuda grass does. And this is one of the things that I've seen a lot of livestock producers that pull hay out, that they'll put the nitrogen on, but they always forget about the P and K. And right now, P and K is very expensive. So it's going to be interesting in the next couple of years to see the effect that this is going to have by people not putting stuff back on their hay fields and as that bottom slide says, or bottom part of the slide says, you know, you're going to get plants like broom's edge come in and other undesirables that basically will reduce the quality of your hay. Well, if you have reduced quality of hay, guess what? You're going to hurt your livestock performance. Again, we have that triad. So you can read through this. I'm going to pass through this one and move on to the next slide. So when you're grazing your forages, it's important that you move these animals in, because there is the nutrient cycling. Because it contributes to our soil organic matter. The grazing action on the plants keeps it in a vegetative state and not going into a reproductive state. Then it encourages root growth, and the roots exudations of plant sugars feed the soil microorganisms. So it is a beneficial process that takes place. And the thing is, in the wintertime, it's much harder because you don't want your livestock out there mucking up the whole pasture. But you need to also keep in mind that when we have those feeding areas, all of the hay pulled out, especially by cattle. Cattle are very inefficient, for the lack of a better way to say it. I mean, they just can pull hay out and lose a lot because they pull hay out, drop a bunch. All of that residue can be applied back to the fields, especially in your lower quality fields, because you're going to have feces, manure. You're going to have those hay residues there as well. And that's very important. And because even those hay residues are going to have additional nutrients that can be cycled back in once they start being broken down in the environment. So when an animal grazes, guess what? They're picking up required nutrients. So we're moving from the plant to the animal health now in our triad. And, you know, we have these, we need all of these minerals. Basically, it's the same minerals that we saw in the previous chart for plant growth. The livestock need it as well. So if you think about skeletal development, calcium, phosphorus, magnesium are really, and chromium are really needed for bone tooth maintenance. Energy, growth, immunity, and repro. What's the first thing to go when you have no energy? Well, that's your repro. So as long as there's good energy in those forages, because it's not allowed to go to a reproductive state, and you have good soil health, your livestock are going to basically get most of what they need. Except one thing we need to keep in mind is selenium. There are a lot of regions, no matter what good our soils are, the forages will still be deficient based on stage of production for selenium. There's a little bit there in Southern Illinois, but we always recommend to supplement, and there are charts to show where the supplementation is. Milk production, and especially the livestock need really high quality forages right after calving or kidding, because guess what? Well, actually, they need it before that. They need a lot of energy. They need a lot of minerals. They need the calcium. They need the magnesium, because they need everything they can do for that immunity and for that colostrum production. Those IgGs that are in that colostrum, that fat that's in that colostrum, that energy is in that colostrum, is very critical for that newborn. And for that dam to maintain that level of production, she needs that calcium and phosphorus. And sometimes we get something called milk fever, where she's just absolutely put out a lot of milk, and there's not enough calcium calcium available for her to make muscle, what's the word I'm looking for, nerve transmission. So she can't move, and it'll kill her pretty quickly if you're not on top of it. So the nervous system function, carbohydrate metabolism, you can read the minerals there. So it is a one health type deal. So you've got your soil health that impacts your plant health, that impacts your livestock health, and then your livestock can go back and actually impact your soil health as well. So these are macro minerals that I was talking about, and you can see the level differences, especially for calcium in your growing calves versus your dry cows versus your lactating. And again, you can just read across there. Magnesium is very important, especially in those growing calves. You can read across there. The take home point on this slide is that each mineral has a particular requirement at a particular stage. So it's always important when you're pulling hay off to have that forage analysis done, and not just look at it from a TDN perspective, but also look at it from a macro mineral and micro mineral perspective. And that's one thing the guys don't like to pay for, but I think it's very important that they get done. So another thing we got to keep in mind is that different plants respond differently to grazing. And one of the prime examples I like to talk about, especially for the sheep and goat people, they really want to put the Lespedeza out. Well, that's fine. In Illinois, it's considered, the Serratia Lespedeza is considered an invasive. But what a lot of people don't realize is the more that those plants get eaten, the more woody they become. So my experience with the cattle in Illinois, they'll eat the Lespedeza once in the springtime when it's nice and tender. After that, they're not going to touch it because it just becomes too tough. They'll munch all the way around that plant. And there are other plants that if you graze them too hard, I'm trying to think, orchard grass. If you put cattle out on orchard grass, they can eat it down way too hard, or even put horses out on horses, especially with the orchard grass. They can overgraze it, and the plants just cannot. They start pulling all the reserves out of the roots, and basically there's no carbohydrate left in there, and the plants just end up withering away. Once that happens, you get way too much competition for unwanted plants, and those unwanted plants then start pulling up all the nutrients that those plants that you do want, and it's a vicious cycle. So keep in mind that not all plants respond the same to grazing, and it's always important to not allow the plants to get overgrazed. So I always tell the guys at least boot height or a little bit taller. Because I'm like, all right, if you graze it down to a nub, basically that's what you're going to have for roots. And you've got to let those pastures rest. That's one of the things the last several years in the fall time, we've not allowed the pastures to rest in southern Illinois, and we're seeing more and more unwanted plants growing. And those unwanted plants are taking up space and nutrients that we really want for our forage pastures. So, and from a livestock perspective, again, we have a multitude of diseases that can arise. One of them is grass tetany, and that's just because we have the plants are growing so fast in the springtime that they're low in magnesium. And under these conditions, you get what's called the tetany, and these animals go down. And if they're not treated immediately, you're going to have long-term issue. Well, the animals will die. That is long-term. You can get some higher magnesium by planting legumes, but that's not a fail-safe. You need to get your high mag mineral out there, and they probably should have put it out about a week ago based on the way the forages are growing right now in southern Illinois. So also keep in mind that high levels of nitrogen and potash fertilization will reduce plant magnesium content. So it's very important when in the fall time to keep in mind from a nutrient perspective when you fertilize these fields and then pull hay off, what's going on with those, or put those cattle out rather. Calcium, sulfates, nitrates, and ammonia can reduce plant tissue magnesium as well. So keep in mind the sulfates and nitrates can come from water sources. We were having problems with one particular farm, and come to find out, we finally got the water tested, and it was high in nitrates. So once we got that taken care of, then everything seemed to go back to normal. I'm going to skip this slide. It's more about grass tetany. It's just more of the clinical processes. So forage quality, we need to make sure that we're harvesting the best. And why? Again, going back to what I talked about, to those cattle that are getting ready to calve, that have already calved, that are out on those fields with the in the springtime with the lush grass. One of the best things you can do is keep, a couple bales of hay out there for those animals and provide the high mag mineral. Those cattle know what they need. That lush forage in the springtime goes through pretty quickly. It just slows down grooming, the pass through, so that helps them out, and they are able to more readily absorb their nutrients. So there's a lot of things that affect forage quality, but there's particle size and other things as far as what the animal will eat. Biggest thing is we end up pulling our hay out way too mature. There's a gentleman that told me the best hay he pulled out was once a year in October. By looking at his livestock, I felt sorry for those poor girls, because they were a body condition score of 4. That was pretty fat on his farm. And the only reason he did it was because that's when he got the biggest volume. And I tried to talk to him, and, it is what it is. Harvest and storage. If you have hay out there and it gets rained on, guess what? It has less quality, because a lot of the nutrients get bleached right back into those fields. Storing it out in the weather, and a lot of studies that show, putting the hay out in the sunlight, you have less vitamin A available. Ends up getting wet. It's if you've got a 5-foot bale, generally speaking, you're going to lose about 30% of that hay outside just because of the weathering forces. So they can almost get all their nutrients needed from forages, but you've got to put up a high quality forage, and that will impact animal performance. And that's, how do you evaluate the performance? Well, how much milk or colostrum is produced? How well did that female bag up? Did she respond like she should? Is she actually producing enough milk for that calf? If she's got a good forage quality, enough nutrients, guess what? She's not going to lose 3 or 4 body condition units. That's the last thing you want the cow to do. You want her to start calving at about a 6. And if she gets down to a 5, that's acceptable. But if she gets below a 5, that is not acceptable, and something needs to be assessed in that. What kind of supplementation based on that forage is. The best way is to look at those analysis, forage hay analysis, and supplement based on the needs of those animals based on their stage of production. So if you got kids and they're on fescue hay versus alfalfa hay, you're going to see a huge discrepancy in weight gains. That's to be expected, because your alfalfa typically is a much higher quality, has a better TDN, more highly digestible than an alfalfa or than a fescue hay for kids. Repro, again, that's one of the best gauges of what's going on in your farm. If you don't have a high reproductive efficiency, something's going on, whether it be a disease or it's a nutritional issue. And again, if there's a disease rearing its ugly head, sometimes it's because they have such poor quality of forages or nutrition. So voluntary intake, if they're not eating the stuff, there's something wrong with it. So animals, if they have a high quality forage, they're going to eat what they need. But if it's a poor quality forage, guess what? That digestibility is going to be multiplied by exponentially, and they're just not going to be able to get what they need out of that. Because guess what? They're going to have room and fill. They can only eat so much in a day's time. And if that poor quality forage grown on poor quality soils isn't meeting their needs, they're just going to slowly go down. And when they slowly go down, guess what? They're going to be susceptible to diseases. So this just shows some really cool, normal graphs as far as trying to fit your production with your forage growth. And a lot of times, especially in Illinois, we have guys that don't match this up. They'll either hit it before or after peak pasture growth. And if you look there, you can see where peak lactation is. If you have a calving date on March 1, it's going to be roughly May 13th, and your peak forage growth is going to be right before that. Whereas if you have a calving date of March 28th, you're going to meet your maximum pasture growth is going to be very close to your calving date. So your peak lactation is going to be well after that. And depending on what's happening with those pastures, your females will not be able to produce enough milk and will be in a negative balance and losing body condition. So matching up your production stage to forage production is also important. So this is just some of the common mineral deficiencies. You can just read through those. One of the things that people don't really think about is the iodine and zinc, the selenium. White muscle disease has been in Illinois, especially in some of our small ruminants. And it comes back to, do we have a good mineral, or do we actually have a high quality forage? And do we know it's a high quality forage? You can buy forage that looks great, but when you get the forage analysis back, it's just not there. So just keep that in mind whenever you're trying to work with this livestock. And again, it all comes back to those soils and how well those soils are built up, and then how well those plants can utilize those soils because of the nutrients from those soils. Because once you have all of those bugs in there, for lack of a better way to say it, you're going to have much better plant growth, and that better plant growth will allow you to have much better feed, whether it be from grazing or from producing hay. So with that, that's my last slide. So I'll be more than happy to take some questions from everybody. I'll give control back to you, Alicia.
All right, sounds great. Do this. All right, do we have any questions today for Dr. Steckler? So while we wait for questions, I will also launch our poll questions for today for you to answer real quick. All right. Not seeing any questions just yet in the chat box, but really greatly appreciate the great information that you've given us. That was definitely really good today. So thank you.
I appreciate the invite. And I must have done such a fabulous job. There aren't any questions. Either that, they're all like, oh my. They need time to digest.
Yep. They need to ruminate on it.
Exactly. You beat me to the punch.
Yep. So,
converting row crop to pasture, where to start? The very first thing to do is go out there and assess the nutrients of those soils. And what I like to do is put on a cover crop and get that that organic matter built back up. And I like the forage turnips, and by taking those forage turnips as well as the ones that go really deep. I'm sorry, I lost the term. Because what they, pardon me?
Be the radishes?
Well, they're the turnips that
Oh,
get the real root. And what they do is they actually break that soil up, because if there's any compaction from the years of tractor work on there, they break it up, they bring those nutrients back up from really deep. And the nice thing is you can actually graze that. And then depending on how large those that area is, you can actually section it off and keep putting cover crops in certain areas, but slowly build up your pasture, because you can't, if you're if you already have livestock and you need that area for pasture, you can't put your, if you plant in the fall, you can't put the livestock out next spring. Those plants have got to have time to set their feet so that they don't get pulled up. So I would recommend, if you plant fall of, let's say 23, then I wouldn't graze it until fall of 24. You might go out once in the summertime, just knock the heads off so it gets back into a vegetative state. But if you do leave 3/4 of it in cover crops, then you still have forages for your livestock while you get the establishment of your pasture. And then you just slowly build up your pastures from there. Is there a role for the soil health tests in pasture? Yes, you can. I like to go out there and evaluate everything. You need to look at what's in the soil structure, because if you've already got a lot of microorganisms, especially earthworms are the best as far as telling you, hey, what's going on? Because if there aren't any earthworms movement in there, that tells me that the soils are lacking in organic matter. And as soon as you start building up that organic matter, you're going to see an improvement in the number of earthworms in there. So there's a couple of different ways you can build up organic matter. So one of the things is, depending on where you're at and what's available, I know guys that have just went out and bought, what's the word I'm looking for? I lost my word. Compost. Sorry, lost my word. So you can actually put some compost out there, or if you, and used to be, right now it's at a premium, if you had livestock producers that wanted to get rid of the residue from around their feed hay rings and things of that nature, they were willing to let you go there and get that up and get it off the farm. Now that's worth some money, so it's going to you have to work out a deal with the producer if they'll even allow you, because that's money, because there's nitrogen, phosphorus, potassium in all of that, and they may want to put it back out on their own fields. You talk about deficits. I have to wonder if these affect stuff I grow in my garden. Oh yeah. Fine soil test hard to analyze. Do I think? Oh God, yes. So in Southern Illinois, I live on the Ag Center, and this is just a really bad clay soil here. So what I have done, Don, is every year for like 4 years, I added lime to it every fall, and I tilled that lime in. And any scraps from the garden, any scraps from the kitchen, I throw in that garden area. And right now, if you just till up the area, well, and the other thing that I've done is I've actually gotten some composted cattle manure and stuff. You got to make sure that it's composted, or it's old manure, because you don't want to put fresh manure on because of the possible for disease transference. You don't want to. There could be potential for problems there. So if it's aged, manure. Like when I had my goats, we had a huge pile every year from kidding and cleaning the barn out. So if it was 2 years old, a year and a half, 2 years old, I'd grab like a truck, well, I should say truckload, like, I don't know, 3 of the mineral tubs. And I'd put that on my garden every year. And now if you look at my garden soil, it's turning into a blackish soil type versus when you start digging out away from the edge of the garden, it's a light tan. So I can grow in my little garden, I can grow so many vegetables now that it's unbelievable. So anytime you can add stuff in, and one of the big things that I always like to do is chop up my eggshells, because we eat a lot of eggs. Chop them up and spread those all over the garden, because that'll actually leach back in the calcium and phosphorus in those eggshells will leach back into the soils as well. Lime, is that alkaline right? My soil is 8.4. Is lime a good idea? What mineral tubs you so yeah, liming will bring the pH back down. If yours is an 8.4, yeah, that you have a well, yeah, that's a bad, you need to add you need to get that closer to a 7. So the mineral tubs that I'm talking about, it's like the livestock tubs that we give our cattle, and they're probably 40 gallons or so. So I've added 120 gallons of dry composted material for several years, plus whatever else. Wow, 8.4. Oof. I do a lot of aged horse manure, and that has not been dewormed. Oh, there you go. That's a good thing. Yeah, because that's the other thing you got to be careful of is where you get your compost from, or because if it comes from a municipality, there is always the potential that there could be some residual pesticides or herbicides. And a lot of the vegetable plants are very sensitive to the herbicides. So yeah, that's a great way to build up the compost. And I would just keep, adding every year and tilling it in. Dan gets annoyed with me because every fall, he's like, I'm done with the garden thing. And I'm like, no, we got to till in some more. So other questions? Brand of mineral tub again. Oh, well, you won't want to buy a mineral tub. These are one tubs that I got left over from that the guys from one of the livestock farms gave me. I'm just reusing them. 5-gallon buckets. You can use a multitude of 5-gallon buckets, stack them up, and carry them out that way. But I just am reusing the tub to carry the composted material from one farm to another. Yeah, the compost. Yeah, it's composted sheep manure. Sheep and goat. And sometimes I can basically get the guys to give me some composted cattle manure. It's been sitting out for years. 12 yards. And you still are not having a good.
I would say that getting that garden limed and pH lowered is going to be, sounds like you've got the organic content there. It's just getting that pH lowered to where it can be utilized.
Yep.
So, yep.
No, you shouldn't be missing any minerals. I wouldn't think. It's just that pH. If you go back to that one slide that I showed you about the availability of minerals, that's in the soil with a pH of 8.4, that's going to bind a lot of the essential minerals for plants. And I don't know specifically which ones off the top of my head, but all those minerals are important for plant growth. And yeah, get that, add a bunch of lime. add lime to, in the fall time, real especially. Add some in the summer or the spring, till it in, add again this fall. Don't we? Oh yeah, you are right.
So it'd be sulfur instead, wouldn't it?
Is it sulfur? I don't know. Oh, you guys put me on the spot. Now I can't think. Very good, sir.
Yep.
At least she's paying attention, isn't she?
Yeah. Thanks, Susanna. Dawn, if you want to send me an email as kind of a follow-up to this, I'll find some information and send it to you on what needs to be. Yep, thanks, Mark. What needs to be put on. So. All right. Well, thank you all very much. We greatly appreciate all of your time and attention this afternoon. And again, thank you, Dr. Steckler, for joining us. And we look forward to seeing you all next Friday, March 10th, for our last Forage Forum Friday with Dr. Keith Johnson and Mark Kepler, talking more specifically about that soil fertility and those indicator plants. So thank you, everybody, and have a great weekend.